Hi everyone! Before we begin, let me share with you what we will be covering in this video. First, we will talk about the definition and example of logically equivalent statements. Second, we will move on to the definition and example of tautology. Third, we will explain the definition and example of contradiction. Fourth, we will look at the definition and example of contingency. And finally, we will go through the definition and example of conditional proposition. These 5 topics are important to help us understand logical statements better. Come on, let's get started.
Hi everyone, today I'm going to introduce the concept of logical equivalent. Logical equivalent is a fundamental idea in logic and mathematics. In simple terms, two statements are said to be logical equivalent if they always have the same truth value. That is, either both are true or both are false in every possible scenario. We use double height arrow symbol like this to denote the logical equivalent. Logical equivalence is very useful in simplifying a logical expression, proving argument, and understand how different logical forms related to each other. Now let me go through to the examples. For example, we use two statements from the rainy day plan scenario. First, Lina said, if it rains, I will stay at home. Then Amir said, if I don't stay at home, then it didn't rain. We also can write it like that. These are logically equivalent. This means that no matter what true value we assign to P and Q, both expressions will always be either true together or false together. Next, I will show you how we can test for logical equivalence using truth table. From previous example, suppose that we want to test whether P implies Q is logically equivalent to not Q implies not P. Here how we create the truth table. First, we list all possible combinations of truth value for P and Q. Since there are two variables, P and Q will have 4 combinations. Then, we compute the truth value of each expression P implies Q and not Q implies not P for every row. Finally, we compare the column. If the truth value match in every row, then the two expressions are logically equivalent. As we can see here, the column for P implies Q and not Q implies not P are identical, so they are logically equivalent. As conclusion, truth table like this make it easy to visually verify whether two logical statements are equivalent. Here, I'm going to talk about importance of logical equivalence. The first one is proof and verification. In mathematics and logic, proving two statements are logically equivalent show they are essentially the same. This is helpful in mathematical proof, theorem, and validating arguments. The second one is programming and software testing. In programming, logical condition can be rewritten into simpler equivalent form to improve code readability, optimize performance, and avoid error. The third one is digital circuit design. Logical equivalence helps in reduce the number of gates used, make the circuit more efficient and lower cost and power. The last one is decision making and artificial intelligence. In AI and decision system, different conditions may be transformed into logically equivalent form to create better rules, reduce redundancy, and enhance machine reasoning.
The second that we have is tautology. Next, we have tautology. Tautology is statement that is always true regardless of the truth values of the individual statements substituted for its statement variables. A statement whose form is a tautology is a tautological statement. For tautology examples, we have 3 variables, which are P is for neural studies, Q is for she will get better result, and R for she consults with a lecturer. The expression that we have is P implies Q and R implies Q implies not Q implies not P or not R. If neural studies, then she will get better results. If she consults with her lecturers, then she will get better results. If she did not get better results, then she did not study or consults with her lecturers. There are P, Q, R, not P, not Q, not R, P implies Q, R implies Q, P implies Q, and R implies Q, not P or not R, not Q implies not P or not R, and the expression in the truth table. As shown in the truth table, the expression results in all true values.
Now we go to the third one, which is contradiction. A contradiction is a compound logical statement that is always false, regardless of the truth values of the individual components involved. This means that in every possible combination of truth values, the overall result of the statement will be false in the truth table. For the contradiction example, we have two variables, which are P and Q. P is I will go jogging and Q is I will eat healthy food. The expression we have is P and not P and Q. I will go jogging, but I do not go jogging and I will eat healthy food. There are P, Q, not P, and the expression in the truth table. As you can see, we get all false in the truth table for the expression.
The third subtopic for logical equivalence is contingency. Contingency is a statement that can be either true or false depending on the truth value. It means that the truth value for contingency is not fixed. It can changes depending on the situation or the input. A truth table for contingency will have both true and false value. This is the example for contingency. First, we have P, which is Ali helps the organization for the event. And then we have Q, Bella helps the organization for the event. And then R, the event happens. After that, we have the scenario. If Ali or Bella helps, then the event happened. If the event did not happen, then neither of them helped. And then we have the expression, which is P or Q implies R, and not R implies not P and R. Next, we have the truth table. The truth table contains P or Q implies R, not P and R, not R implies not P and R, and the expression P or Q implies R, and not R implies not P and R. After done the truth table, we can get the truth value, and the truth table shows that the expression earlier is contingency.
Lastly, I will explain to you about conditional proposition. Let's look at the terms one by one. Let's start with implication. An implication is a statement that says if A happens, then B happens. It shows a cause and effect of a condition and result relationship. Next is the converse. The converse is made by switching the order of the implication. So instead of if A then B, if it becomes if B then A. Now let's look at the inverse. To form the inverse, we take the original implication and make both parts negative. It becomes if A does not happen, then B does not happen. Finally, the contrapositive. This one is made by both switching the parts and making them negative. So it becomes if B does not happen, then A does not happen. Here's a simple example. Now, the implication is given if a student studies hard, then they will pass the exam. In this case, we define P is the student studies hard and Q is the student passes the exam. Now let's apply the forms. For converse, you have to reverse hypothesis and conclusion. In variable, the answer is if Q implies P. In sentence, if a student passes, they studied hard. Next, inverse. Just use the original one, but you have to put note on hypothesis sentence and put note on conclusion sentence. In variable, the answer is if not P implies not Q. In sentence, if a student doesn't study, they won't pass. Lastly, contrapositive. For contrapositive, the hypothesis will become conclusion and the conclusion will become hypothesis, and put note in conclusion and hypothesis sentence. In variable, the answer is if not Q implies not P. In sentence, if a student didn't pass, they didn't study. So, from all of this, each one has shows the relationship in a different way.
We can conclude that if two statements are logically equivalent, it means they are true under the same condition, they are false under the same condition. One statement can be replaced by the other without changing the meaning or outcome of an argument. There are many ways to determine logical equivalence, such as the first one, truth table. Create a truth table for both statements and verify if the truth values match for all possible scenarios. The second one, use logical laws. Use logical equivalence such as De Morgan's law, double negation, or distributive laws to rewrite one statement into another. The third one, contrapositive or conditional proof. For conditional statement, check their contrapositive forms or deduce one statement from the other.
Got on my leather jacket.